Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and today we have an awesome show for you. I'm really looking forward to it. We're speaking with an accomplished physicist, author, and Catholic who's on the front lines of faith and science discussions, Professor Stephen Barr. Professor Barr, welcome to the Purpose Nation podcast.
Well, thank you for having me on.
Well, we're very glad to have you on. It's also a great timing having you on the show today. So today is November 15th, and I believe this would be, for Catholics, the feast of St. Albert the Great, who, as I understand it, is the Catholic patron saint of sciences.
He is indeed, and that's right. And in fact, he lived in the 13th century, and he was actually a scientist and a bishop and a theologian and a philosopher. Yeah, so that's why he's the patron saint of scientists. He actually did some significant scientific work.
Well, that's interesting. So great. It's a blessing to have you on the show today. As I understand, he was also a mentor for St. Thomas Aquinas.
Yes. Yeah, he was his teacher. Right.
He also seemed to be very broad, and so he did all kind, as you mentioned. It's kind of rare today, right, to have that sort of person where they cover philosophy and theology and sciences, and he sort of seemed to be a jack of all trades. That's
one of the problems of the modern world. There's so much known, and it's very hard to know everything. I mean, there were people in the distant past who knew just about everything that was known in their time. That can't be so anymore, unfortunately.
Yeah, I mean, well, they didn't even really have physics sort of specialize in particle physics or grand unified theories, which we're going to talk about in a minute, would be sort of unheard of. And then there's also something, and I'm just curious too, something called a gold mass today as well.
Oh, yeah. Yeah, that's a brainchild of me and some friends. The thing is, we think that religious scientists in general, and Catholic scientists in particular, need to get to know each other and have some fellowship with each other. There's really a sort of isolation. Many people who work in the sciences or science education don't know about the other religious people in their field. So we had the idea of having a gold mass. It's based on the tradition. Every year in many places there's a red mass for lawyers. That dates to the Middle Ages. And there's something called a white mass for medical personnel and a blue mass for law enforcement people. So we thought, why not a gold mass for scientists? And that way, at the local level, once a year, they could worship together and meet each other and have fellowship. That was the idea.
That's great. That's amazing. And you just started that, when was that, this year or last year? Or?
Well, we had the idea a couple of years ago. The first one, just one was held last year, and that was at MIT. This year there's 7. I hope by next year it'll be dozens, and we hope it takes off to form a community. Religious scientists need to be more of a community with each other.
I really like that.
Mutual support.
Yeah, that's fantastic. Yeah. And so is that mainly at churches within universities, or is that open, do you think, to all parishes? Or?
Well, it actually seems to be starting at, I think it's more likely to be able to get off the ground quickly in places that are university towns or big cities where you have relatively large numbers of scientists and science educators. It would be harder to do that in a small town.
Well, hopefully, once you and us here at Purpose Nation and we kind of make some ground roads, then hopefully there should be lots of communities out there. It doesn't have to be university communities who are fans of science and people out there. So let's have lots of gold masses around the country and around the world. I really like that. So thank you for doing that.
That's our goal. We hope this catches on.
Well, we'll do our part to help, and we'll put some information on that on our podcast page. So before we get into too much further, though, I did want to give a quick background for Professor Barr. Very impressive background. He's been in the fields of science and physics for many, many years. He is a professor in the Department of Physics and Astronomy at the University of Delaware and is also the director of the Bartol Research Institute. He has a PhD in physics from Princeton, great school for physics there. He does research in theoretical particle physics and things like, if you don't understand what some of these things mean, that's okay. Grand unified theories of CP violation, neutrino oscillations, particle cosmology, some really fantastic stuff with big words. So hopefully he can help us understand a few of those words here in the conversation. He's also a fellow of the American Physical Society, and and I'd love to dive more into this later, he's also a co-founder of the Society of Catholic Scientists, which we'd love to hear more about. His work, and he's appeared on many different programs and news outlets like First Things, National Review, Wall Street Journal, Weekly Standard, EWTN, lots of different news outlets. And he's also he's an author and written some great books, and one of them talks pretty deeply about the intersection of science and religion called Modern Physics and Ancient Faith. And so we'll also have a link to that on the podcast. It's a great book. Definitely recommend you go out and check that out. So actually diving right into that, Professor Barr, if you could tell us a little bit about that book and sort of some of the origins behind it. What were some of the reasons that you decided to write that book, and what were you hoping that people would come away with it?
Well, I've always been annoyed or impatient or disappointed that so many people think that there's a conflict between science and faith. For many years, I dreamed or toyed with the idea of writing such a book. Now, the thesis of my book is that there were many developments in science up until, say, the year 1900, that many intelligent people, many reasonable people who were not hostile to religion, thought somehow undercut a traditional Jewish Christian view of the world, a biblical view of the world. But in the 20th century, many things have suddenly gone the other way. There have been, as I call them in the book, twists in the plot. Science seemed to be moving in a certain direction, and then all of a sudden in the 20th century, it started pointing in the other direction. And so that's what my book is. It's about 5 major developments, especially in physics, which is my field, that I say are more consonant with, more consistent with a biblical view of the world than with an atheist or materialist view. And so that's in rough outline what the book is about. And I talk about the Big Bang, just take one example, the Big Bang. Before the 20th century, it was becoming increasingly the belief of scientists that the universe had always existed for infinite time. But then in the early 20th century, with Einstein's theory of gravity and some other developments, the Big Bang theory was formulated, and evidence began to accumulate that the universe did have a beginning. And so that's a major twist in the plot. And of course, Christians and Jews have always believed that the universe had a beginning, as the first words of the Bible say, in the beginning. And so that's one of 5 topics I talk about, including quantum mechanics and other things that I claim throw a monkey wrench into the atheist's story of scientific history.
Yeah, and so sort of the origin of the book that you mentioned, I'm with you there. I sort of want to one day turn on, a news program or something like that, and they're interviewing somebody like Lawrence Krauss or Richard Dawkins, and they say, now, why don't you believe in God? There's all these other scientists out here who believe in God. Why don't you? But normally, but usually what I see is you or some other Christian believer who's a scientist, getting asked, well, what do you think of the conflict between faith and science? It always makes me make the assumption. It sounds like that's what you're saying too.
Yeah, and I should say this, many scientists are religious and many scientists are atheists. I don't know which is a larger number, but in my experience, scientists who are atheists were atheists before they went into science. That is, it wasn't that they lost their faith or they discovered something in science that convinced them there's no God. Mm-hmm. Many of them were atheists to begin with, and so it's not the science that made them atheists.
Right.
That should be understood by people.
Right. But your point's well taken. And then also the history, too. And that's something I totally agree. It seems like people have lost sense of the history and the contribution that very faithful Christians have made to sciences through the centuries.
Right. That's one of the major contributing factors in people thinking that there's a conflict between science and religion. They have a completely erroneous conception of how the history of science. There was not historically a battle between the religious people and the scientific people. For the first several hundred years of modern science, from the time of Copernicus up to maybe the late 19th century, most of the great scientists were religious. Mm-hmm. The religious people and the scientific people were the same people. Right. There weren't warring camps. And if you look at the great figures of the scientific revolution, Isaac Newton and Boyle and Descartes and so on, and Galileo, they were all religious.
Right.
They actually saw their work as showing the beauty of God's creation, as showing forth God's glory in his creation. They did not think this somehow was opposed to religion. That's a complete myth, and that myth only arose maybe a little over 100 years ago.
Right, and you definitely go through in detail in some of that in the book. Definitely recommend people check that out to get more background on that. Tell us about some of your current physics work. So what are some of the key questions or things that you're working on in physics?
Some of the questions I've been working on for many years, because the big unsolved problems in my field of physics have been around for many decades and remain unsolved. So one of the things that I've worked on ever since my PhD, which is 40 years ago, is a big puzzle having to do with the masses of the fundamental particles. So among the fundamental particles, there are 12 particles that you might think of as the kind of particles that compose matter. For example, electrons and quarks and so on. And those 12 particles all have different masses, and the masses are all over the place. They span a very big range, but it's clear that there are patterns there. There are mysterious patterns in these 12 masses. And it's not just patterns in the masses, but these particles mix with each other in a certain way, described by certain angles. And there are patterns in there also. And nobody understands where these patterns come from. So they're not random. It's like trying to decipher some language, that with a Rosetta Stone or something. It's trying to unlock some or crack a code. And no one has been able to do this. And I've written a lot of papers on this this subject, and I think I've had some good ideas on it. I also work on grand unified theories. They've been around for quite a while. There are three forces besides gravity. Gravity is kind of off by itself. It's a very different kind of force. But the three non-gravitational forces can be unified. There can be a unified mathematical theory that embraces all three. And those are called grand unified theories. And that is a very big subject of research for over 40 years. And that's one of my areas of expertise. And I spent a lot of time studying grand unified theories.
That's great. Those are very exciting, and I would like to hear a little more specifics about that in a moment. I do want to take a step back, though, and maybe have you tell us a little bit about how you got into all of this craziness. So what point in your life did you say, I really want to understand the grand unified, come up with a grand unified theory that unites all of these very interesting, and the puzzle that you mentioned?
I guess it all goes back when I was a little kid. Well, I've been both religious and scientifically oriented since I was very small. What really attracted me as a kid, and I'm talking about a very small kid, is mathematics. I loved it. I used to spend a lot of time reading books on what's called recreational math, puzzles, brain teasers, and so on. And so I fell in love with mathematics. And I always somehow knew I was going to go into science. I don't remember a time when I said, I want to go into science. It was sort of always there. I used to read a lot of books as a kid on science and astronomy, geology and stuff. And so that was sort of my path from the beginning, and I've never thought about it, really. And I was attracted to physics specifically because it's the most mathematical branch of science. And it also deals, well, this may offend people in other branches of science, but it's sort of most fundamental branch of science. And within physics, some people think that particle physics is the most fundamental branch of physics. Again, I might offend my colleagues in other branches of physics, but that's what we think, is that we're the most fundamental branch of physics. And so I was attracted to that. The grand unification attracted me. That was what I really have worked, probably a third of my work has been in that area. What has struck me, one of the first technical physics research papers I ever read when I was a graduate student was the first paper on grand unification, written in 1974. And it was so beautiful. I mean, the way all of the forces fit together mathematically and the way the different kinds of particles fit together mathematically was so elegant. It was like some sort of a very beautiful gem, It was just something so beautiful about the mathematics that I figured it had to be right. That's the feeling of most physicists, actually, about this. And that drew me in, and that became a big area for my work. And I should say, it also attracted me because I like to see how things fit together. Okay, I see the world as a place that should make sense, and things should fit together in some coherent way. And that's not just the different forces of nature should fit together, but our scientific view of the world and our religious view of the world should fit together. It sort of appeals to my belief that there's a deep harmony to everything, and that everything should have some coherent relationship to everything else. And that probably is also why I thought a lot about science and religion questions over the years.
Mm-hmm. And did you have any family that were either professors or in the sciences or in kind of this kind of similar kinds of fields or math, or were you sort of the black sheep of the family in terms of your love of math and science?
I guess on the lone sheep. My father was more in the humanities. He was a highly educated person. He was an instructor at English at Columbia University, and then he became, interestingly enough, an assistant dean in the engineering school there. He was very interested in science and math and knew a lot about science and math. I think he was very talented. He could have gone into those fields, but he didn't go into science. But he's the closest, I'd say, to a person having a scientific orientation in my family. None of my 5 kids have gone into science, so they're all very smart when it comes to those kinds of things. But no, I seem to be the only one. None of my 3 brothers, none of my 3 brothers went into math or science either. So yeah, I'm kind of the odd man out here.
Right. No worries. I'm with you. I had 3 brothers, and I was the nerdy guy of the family too, the geeky, nerdy science and math guy. And how about as far as the Catholic faith? So it sounds like you had a Catholic upbringing.
Right. Yes, I was baptized as an infant, and I was raised in a Catholic family. My father actually was not religious. He called himself a skeptic, and he was not from a Christian background. But though he eventually, after my mother's many prayers over 50 years. My father was baptized when he was 79 years old, thanks be to God. But when I was growing up, he was not religious, but he took very serious. He wanted us to be raised Catholic. My mother was, of course, Catholic and very devout, but my father took it very seriously that we should be raised Catholic. But it was interesting growing up because I knew that he wasn't religious. And so that, I think, is one of the things that made me think in a critical way, ask questions about my faith, because I saw somebody who was, to me, of course, a tremendous person I revered above all others, who I knew didn't share my faith. And so gave me a more ability, I think, to critically analyze these issues.
Mm-hmm. A lot of Christians, after they go into college, seem to either fall away or face challenges in their faith. Did you experience any of that?
No.
Scientific people challenging you, or did you run into any of that as well?
Well, I didn't. I've never lost my faith. I like to say that when I was a child, I had the faith of a child. Suffer the little children to come unto me, right? I mean, so I received faith as an unmerited gift, right? A totally gratuitous thing as a child. And I've never had any doubts in the sense of thinking that the whole thing was wrong. In particular, I would say the existence of God always seemed to me luminously self-evident. I have never even for an instant been able to put myself into an atheist frame of mind. It just seems to me, in my mind, self-evident practically. And also the divinity of Christ always struck me as something that I couldn't doubt. But here's the thing, a lot of Christian belief, teachings, and doctrines and so on, I struggled with, they created intellectual difficulties for me, not because of science, because of other things, actually, philosophical or historical issues, but they had difficulties with some of them, never the moral teachings. Right. Of the faith, but with other things. And so I thought a lot and I read a lot. I only went to Catholic school up till I was 10. I'm self-taught in these areas, and I did a lot of reading of history, of theology, and so on, scriptural commentaries and so on. But I've thought a lot over the years about these issues because these questions would bother me. They'd nag at me. As a scientific type, I ask a lot of questions. And I want the answers very badly. So I was very much interested in working through these issues. And that's what eventually led me to write a book, because after 20, 30 years of thinking very hard about many issues, I felt that I had something to say that might interest people.
And so very ingrained in your faith, and couldn't imagine, as you said, being an atheist. Also, is the same true of physics? Could you ever have imagined yourself doing some other career? Was there a second choice for you? Is there some other hobby or some other, you want to be a musician or a sports athlete or any other?
No, not really. I mean, in fact, it's kind of a funny thing. When I was applying to graduate school, I applied to Princeton, which is, as you said, that's where I ended up going and getting my degree. But Princeton asked applicants to the physics graduate program to write a 1,000-word essay saying, first, why they wanted to go into physics, and second, why they wanted to go to Princeton. So I said to my father, who was an educator, I said, I don't know, I've never written one of these before. What do I say about why I want to go into physics? And he said, what you should write down is, to dig I am unable, to beg I am ashamed. Those who've read the King James Bible will recognize from one of Jesus's parables. So basically, I can't do anything else. I can't dig ditches, and I'm too proud to beg. So what am I going to do except physics? It was kind of, I can't see myself doing anything else. I'm not cut out for anything else.
I love that.
If I didn't, I didn't put that down, but then many years later, I asked my former thesis advisor. I told him that, and he said, you should have put that down. People on the admissions committee would have found that very funny, but I was afraid to.
Right. Oh, like I said, maybe there's some people out there listening who are thinking about what to write on their applications right now. That's a good suggestion. I have no second choice.
I have no second choice.
What's your second choice? Field? None. Good. Well,
none.
That's excellent. And so that brought you into the fields that you're in today. So going back to that again. So you talked about the grand unified theories, and you mentioned that this has been decades now that, so you said 1974 is when you first sort of learned of it and got into it. And many scientists have been after, chasing this, if you will, the holy grail of physics. So do you see some light on the horizon here, in terms of this issue? And I mean, do you think we're on the cusp of making some discoveries that will get us any closer to some grand unified theory?
Well, there are a lot of grand unified theories, to take that example. The question is which one, if any of them, is right. And people, the one way to find out, the one most promising way to find out there is to find something called proton decay, to show that protons are unstable particles. And people have been doing more and more sensitive experiments since the late 1970s, and sadly, so far no one has seen any evidence that protons are unstable. And so we don't have the proof. Are there going to be big breakthroughs in my field? A lot depends on what they will see in the LHC, this Large Hadron Collider, which is this very big, I guess you'd call it, atom smasher that is built at CERN in Geneva, Switzerland. It's been running for a number of years, and it discovered the Higgs boson, but that was expected. The big question is, will the LHC discover anything radically new, anything that's not really part of our current theory? And so far it hasn't. I think it has more years to run, I think the chances it's pretty iffy. The chances are probably 1 in 2 or 1 in 3. That's what I would guess, that they'll see something radically new. And if they do, of course, that'll lead to a huge breakthrough. If they don't, then it's hard to know when a big breakthrough will come. It may not be for a long time.
Are there other experiments out there? Yeah, I mean, so I think I've heard of something called the Muon Collider, and there's other different, dark matter experiments. Are there other things that, in terms of experimentally, that might lead us in some new and interesting directions?
Yes, there are several things that could also lead to a breakthrough. One is what I said earlier, looking for protons to decay, and people are still doing that. And I still have hopes that someday, before I'm dead, they'll see protons decay. That is a quite lively hope at the moment. Another one is, as you said, looking for dark matter. Much of the mass in the universe is in the form of particles whose nature we don't know, but we know they're out there. So people are doing experiments to detect dark matter, either detect dark matter particles that are out there impinging on the Earth, or to detect dark matters by producing them in accelerators. Another one is close to my heart is, and this sounds very technical, is looking for electric dipole moments of certain fundamental particles, of the electron in particular and the neutron. It's a certain property that particles can have, but have never been observed to have. There's reason to believe that particles should have these electric dipole moments, and if they're measured to exist, that would have very, very big consequences. That would be a very big breakthrough. And so that's another place where something important, exciting could happen.
Is that difficult to try to measure? I mean, what are some of the...
Very difficult. And interestingly, though, the LHC, these big accelerators or colliders, they cost many billions of dollars and are miles in size. These experiments that measure electric dipole moments are done on tabletops, and they cost in the range of hundreds of thousands of dollars. But these experiments, which are very, very difficult to do, these experiments, if they find something, that would have big implications. So there are a variety of things that could lead to a big breakthrough, but I have to say this. What you need is the LHC or some comparably big machine to find something. You need if you don't have things discovered at accelerators, then the field is starved for data. Those are the workhorses of the field.
Right.
And if they're not producing breakthroughs, then you're in trouble.
Changing gears a little bit, but if you could ask God, let's say you had him in front of you for 5 minutes, you could ask him one science question. What would that question be?
I thought about this, and I think if God were in the presence of God, I would be thinking about other things. Like my wretched spiritual state. I'd be afraid that he would say,
after you got through all of that, and
I would be afraid he'd say, I was hungry and you did not feed me, and I was thirsty and you did not give me the drink, and send me away with the goats.
You are forgiven. All of that's forgiven, and now what's your...
Okay, yeah. So actually, after the important stuff is taken care of, I guess what I'd probably ask him is the universe infinitely large, or is it of finite size? And I think that's a very philosophical, that has a lot of interesting implications if it's infinitely large. And it's also something we're probably never going to know. It's hard to imagine how we'll ever know the answer to that by empirical investigation. So I'd also like to know there's other things. I'd like to know if any of my, are any of my theories right? I have various things that named after me and theories and models. And I'd be sort of curious.
I saw that, yeah. So you're going to have to tell us what the Barr Z diagram is in the Nelson-Barr mechanism. I saw those, but I don't know what those are.
Well, they actually both relate to this CP violation you mentioned earlier. It's a little esoteric, but it actually touches on things that are easy to explain. CP is a certain symmetry that relates particles and antiparticles. And if CP were a symmetry of the world, then the world would treat particles and antiparticles exactly the same. But we know that the world doesn't treat them the same, because almost everything in the universe is made of matter. There's very little antimatter around. So CP, as we know, is violated. This symmetry is slightly broken. And that's very good for us, because if there was an equal amount of matter and antimatter in the world, it would all have annihilated.
Right.
And if it had all annihilated, there'd be nothing left to make people out of, or planets or something. Yeah, and so it actually, what the belief is that in the early universe, soon after the Big Bang, there were equal amounts of matter and antimatter because of the CP symmetry, basically. But there's a slight imbalance. There's a slight fly in the ointment. There's a slight asymmetry. Just so like someone's face could be more or less symmetrical, but if you look really closely, it's not quite. So the laws of nature seem to be CP symmetric, but we also know there's slight asymmetries there. And those are what somehow tilted the universe in favor of matter, and so we ended up with entirely matter. CP is also related to the question of whether the laws of physics work the same backwards and forwards in time. That is, do the laws of physics that operate on the microscopic scale, do they know the difference between past and future? And, well, that's a very profound question. And another question is, are the quantities that appear in the laws of physics, are some of these quantities real numbers, as mathematicians call them, or complex numbers? That's also. So it ties into some very deep issues in physics. And so something called the Nelson-Barr mechanism. The failure to find a certain violation of CP that people expected to find is called the strong CP problem. And there are a couple of popular ideas or promising theories to solve this problem, to explain why we haven't seen these violations of CP. And one of them is called the Nelson-Barr mechanism, which is named after me and a physicist named Ann Nelson. The Barr-Z diagram actually has to do with something I referred to before. It's called a Feynman diagram. It's a process that goes on at subatomic distances, basically, a quantum mechanical process that should lead particles like electrons and neutrons to have electric dipole moments. And by the way, those are also a consequence of what's called CP violation. CP violation implies that these particles should have these electric dipole moments, and the Barr-Z diagram is a mechanism by which that happens. A lot of these tie together.
And it's great to have, I love how physicists and physics always has different things named after folks. So, and I'm glad you have some things named after you. I'd love to have, podcast, a Cooper podcast format. I'd love to have something. I don't think I'm going to have anything named after me anytime soon, but it's awesome to see those things. And that's a great question to ask God. And and I hope you're on the right track with some of these things. And hopefully we can make some discoveries that will, God will say, well done, good and faithful servant. You're on the right track.
I have a feeling that God is going to keep a lot of the answers to these questions hidden from us.
Could be.
Which is both, maybe that's nice and maybe it's not so nice. It's not so nice for the physicists. We're having a hard time answering some of these questions.
Yeah, he might keep some of them a little close to the vest. What about, real quick on this one, and then I want to get to another topic here, but the multiverse. Yeah. I mean, what is your thought on that? Because that is also something that it seems that atheists have in their back pocket to say, well, maybe all of these different constants and things that line up very well, indicating that there could be a creator. Well, we're out of that because we have the multiverse. I mean, do you think that is just a valid scientific theory?
Well, I take it very seriously. I think it sounds a little crazy or wild to the non-scientist, the non-particle physicist, but actually the multiverse idea, which comes in different versions, there's different ways of having a I think it actually is very plausible from the point of view of fundamental physics, and I would not be at all surprised if we live in a multiverse. As you say, it can be used to explain certain things in the laws of physics. There are certain things in the laws of physics that seem to be just right to make the universe able to have life in it. If you take the laws, take certain constants of nature, for example, as we used to think of these things, and you change their values by a little bit, you find that suddenly the universe would change in a dramatic way that would make it impossible for life to appear. So it looks like these constants of nature were kind of selected deliberately, fine-tuned even, to make the universe habitable. And that could be an argument for the existence of God. The multiverse is a way, at least partially, a escape hatch that an atheist could use. He could say, well, actually these constants of nature are not constants. They take different values all over in this large thing called the multiverse. And only in those regions where they have the right values for life does life appear. In other words, it's like nature tried all the possibilities, and there were bound to be places in the universe where things lined up, as you said, just right for life to appear. This might be true, except one, we'll never know. I think the multiverse idea is pretty much inherently untestable. And two, it doesn't necessarily get you out of the argument for the existence of God, because the way I like to say it is we now realize that the laws of physics have to be very special if you're going to have a universe that has life in it. And multiverses are themselves very special types of universes. So either way, if you tell me these constants of nature were fine-tuned and adjusted, or you tell me that the laws of physics are such as to give you a multiverse, either way, the laws have to have something very special about them if you're going to have a universe with living things. And I think that suggests that whoever cooked up this universe wanted there to be living things. I still think you have that argument.
Right. Okay. So shifting gears a little bit more. So science as a sort of a calling and a vocation, there are different studies that you've probably heard statistics on the prevalence of believing church-going Catholics in the fields of science. Physics, to me, seems like a field where it's actually fairly good representation, and I think it probably has a lot to do with what you were discussing earlier. It's sort of those deep questions about the fundamental laws of nature and of God, and so it seems like there's a decent number of physicists, but there, in other fields like biology and in chemistry and other and technology fields as well, it does seem like there is a lower percentage of Christians in these fields, at least for your field or other science fields. Why do you think that is? And then are there things that we could do to maybe turn that around and change a little bit?
Well, I'm not sure it's true. I mean, there have been studies, and I have seen studies that suggest that you have similar percentages of Christians in different fields of science. So I'm not sure physics has more than chemistry or biology or some of the other. Right. So I'm not sure there's actually really a difference between the fields.
Now, for you personally, I think I maybe even seen it in an interview where you said, well, there's actually some of my colleagues who actually were Christians, but you didn't know it for years because they weren't as out front. Now, maybe that's a way to rephrase it. Let's rephrase it that way. Right. How can we get Christians who are in the fields of science to maybe be more out there in front with their faith? Because otherwise, we do have the media latching on to the Lawrence Krauses and the Richard Dawkins, and there was a study done to show how many people recognize the name Francis Collins and who he was, and he's obviously a prominent biologist, and 4% of the population knew who he even was. 5 times as many people knew who Richard Dawkins was. So what is that? Are you seeing that in your fields as far as, well, there may be people there, but they're just sort of hiding?
Well, I think the thing about Hawking, for example, he is one of the great physicists alive today, and one of the greatest, and that's part of it. But there's also a certain mystique about him. There are certain scientists who just catch the popular imagination. Einstein, and Hawking is one of them. And then everybody's heard of certain people. Heisenberg, everyone's heard, not just because of the show Breaking Bad. A lot of people have heard of Heisenberg, Isaac Newton. So it's hard to break into that class where everybody knows your name. So there are people in my field, for example. There's a person in my field who is as great, I think most people would agree, as great a physicist as Hawking, certainly in that league. And he's a practicing Catholic, but I suspected not just 4%, but maybe a tiny fraction of 1% of people have ever heard of him. But he is a giant in the field. And I guess we have to do a little better job of being vocal. I think part of the problem is that believers, not just in science, but in the academic world, tend to play their cards close to their vest. They're not very vocal and open, and there's some survival reasons for that, because in the academic world, there are a certain small, but not zero percentage of people who are prejudiced against religion. And so a lot of young people, especially in the sciences, they don't want their careers snubbed. They don't want some person who's looking at their job application, for example, to find out that they're religious and they don't get the job and their career's cut short. A lot of religious people are sort of quiet about their faith. As you said, there's a person in my department who I was a colleague of for 20 years before I found out that he also was a practicing Catholic. That just shows you how people keep it to themselves. And as a result, scientists who are religious often feel isolated because they don't know anyone else, or they only know a few people in the sciences or in their own field who are also religious, when there might in fact be large numbers of them, but they don't know that. And I think this is one of the things also, not just with professors, but with grad students and undergrads. When I was an undergrad or a grad student, I didn't know the name of any big scientist who was religious or any of my professors, and very few of my fellow students. And so I felt this terrible sense of isolation and being out of step, which it could be very psychologically trying for people. And that's one of the reasons we started this Society of Catholic Scientists. As we're coming out of the closet, so to speak, other people are coming out of the closet. Right now, we've only started 16 months ago, and we have about 600 members. And that's all with almost no publicity, just by word of mouth, basically. It's because a lot of religious scientists are hungry to connect with other religious scientists and to show the world, there are lots of us. Our name is Legion, And I think that's part of the solution to the problem. There's strength in unity and in numbers. And when they start making their existence known to each other first and then to the world, I think it will help overcome this impression that the scientific world is a hotbed of atheism.
Yeah, that's great. I'm glad you mentioned the Society of Catholic Scientists, and you have a conference. I believe it's a yearly conference. So was last year the first year for the conference?
That was the first year, and that was the first, and we only had 300 members, and about 100 of them showed up up at the conference. So by the next conference in June, we should probably have 700 or 800 members. So we're looking for an even bigger conference. And people can go to our website. If you just Google Catholic scientists, you'll find the Society of Catholic Scientists easily. Right. And all the talks from the first conference, you can view them, the videos, on the website and get a sense of who we are.
Great. Yeah, we'll have a link as well to the Society of Catholic Scientists website, so please do check them out. They have an email that you can sign up for and get more information. Now, can anyone attend the conference?
It's for members, and we do have pretty strict membership requirements, I have to say. If you are a scientist in the natural sciences, physics, chemistry, biology, geology, earth sciences, or math or computer science, we count those two, and you have a PhD in one of those fields, and you are a believing and practicing Catholic, then you almost certainly qualify.
Great. Yeah, we'll definitely have a link to that. Sounds like a great organization. Just glad to see that it's growing and getting out there. And as you said, sort of helping some practicing Catholics and other Christians in other organizations. There's other scientific organizations for Christians as well, other Christians.
Right. By the way, our keynote speaker at our first conference was a devout Protestant, a very eminent cosmologist from Cambridge.
Great.
And so we're ecumenical. It's not just Catholics speaking at our conference.
Sounds good. Yeah, we are as well. And so obviously we have Catholics and other Christians who are on our show. And we do hope that science somehow will unite Christian faiths together in a common cause, and in a way that we can use science to glorify God and to fulfill our command to sort of love and serve each other as well. So we're very ecumenical, and that's good to see. And I definitely look forward to seeing the presentations that come out of that next year as well.
Yeah, we're all fighting the good fight against atheism and materialism. On those issues, I think the doctrinal differences between different Christians and Jews and religious Jews also are on the same side on these issues, believing in God, believing that we have souls, that we're made in the image of God, and these very fundamental beliefs are one thing that brings us together.
Agree. Amen. So we have Thanksgiving coming up. Looking back, is there something that you can point to maybe back in your career that you're thankful to God for?
I have to say, fundamentally, the thing I'm most grateful for is that I exist at all. I mean, God is the source of being. He is the creator of all things. Everything we have, our very existence, our minds, our bodies, everything, our senses, our faculties of reason, our ability to see and smell and hear and everything, and our intelligence and skills, everything is a gift from God. And so I'm grateful for everything. I really can't pick one thing out and say I'm grateful just for that, because I'm grateful for the whole thing. I wouldn't exist at all unless it were God's creative power. And of course, for the gift of faith, I suppose, if there's one. Other than the fact that I exist at all, it's for the gift of faith.
Amen. Well, and we're thankful that you are out there on the front lines. Sounds like exhibiting your calling to use science to explore God and His creation and His nature. So we're thankful for that, Professor Barr, and thankful for having you on the show today. So any gold masses that you're going to be able to run out to today?
No, I dropped the ball on that. I should have organized one in my area in Philadelphia, but I didn't do it in time.
Okay.
But I'm hoping that next year and the years after, it's going to keep growing and helping the scientists and science educators, even high school science teachers, and get to know each other at the local level. And
yeah, well, hopefully next year we'll be the next time we're talking, you'll have one in your area, and we'll have one in ours here too, and we can go check it out. Well, thank you so much again, Professor Barr. It's just been a pleasure to speak with you. We're so thankful that you're out there, leading the way in both physics and just so many of the things that you're involved with there, as well as being on the forefront of bringing Catholics together to support each other. So thank you so much for joining the
and thank you for having this show and for all the things that you're doing in this area.
Appreciate it. Professor Barr, thank you so much for joining us today. God bless, and hope to talk to you soon.
Okay, very good. Thank you.
God bless. Thank you.
Thank you for joining the Purpose Nation podcast. For more great interviews, resources, or to make your tax-deductible contribution to support our nonprofit ministry, please visit purposenation.org. This program is copyright Purpose Nation, Inc., a 501c3 nonprofit corporation.
I dreamed or toyed with the idea of writing such a book. Now, the thesis of my book is that there were many developments in science up until, say, the year 1900, that many intelligent people, many reasonable people who were not hostile to religion, thought somehow undercut a traditional Jewish Christian view of the world, a biblical view of the world. But in the 20th century, many things have suddenly gone the other way. There have been, as I call them in the book, twists in the plot. Science seemed to be moving in a certain direction, and then all of a sudden in the 20th century, it started pointing in the other direction. And so that's what my book is. It's about 5 major developments, especially in physics, which is my field, that I say are more consonant with, more consistent with a biblical view of the world than with an atheist or materialist view. And so that's in rough outline what the book is about. And I talk about the Big Bang just take one example, the Big Bang. Before the 20th century, it was becoming increasingly the belief of scientists that the universe had always existed for infinite time. But then in the early 20th century, with Einstein's theory of gravity and some other developments, the Big Bang theory was formulated, and evidence began to accumulate that the universe did have a beginning. And so that's a major twist in the plot. And of course, Christians and Jews have always believed that the universe had a beginning as the first right.
Where they cover philosophy and theology and sciences, and he sort of seemed to be a jack of all trades.
That's one of the problems of the modern world. There's so much known, and it's very hard to know everything. I mean, there were people in the distant past who knew just about everything that was known in their time. That can't be so anymore, unfortunately.
Yeah, I mean, well, they didn't even really have physics sort of specialize in particle physics or grand unified theories, which we're going to talk about in a minute, would be sort of unheard of. And then there's also something, and I'm just curious too, something called a gold mass today as well.
Oh, yeah. Yeah. That's a brainchild of me and some friends. The thing is, we think that religious scientists in general, and Catholic scientists in particular, need to get to know each other and have some fellowship with each other. There's really a sort of isolation. Many people who work in the sciences or science education don't know about the other religious people in their field. So we had the idea of having a gold mass. It's based on the tradition. Every year in many places there's a red mass for lawyers. That dates to the Middle Ages. And there's something called a white mass for medical personnel and a blue mass for law enforcement people. So we thought, why not a gold mass for scientists? And that way, at the local level, once a year, they could worship together and meet each other and have fellowship. That was the idea.
That's great. That's amazing. And you just started that, when was that? This year or last year? Or?
Well,
he has a PhD in physics from Princeton, great school for physics there. He does research in theoretical particle physics and things like, and you know, if you don't understand what some of these things mean, that's okay. Grand unified theories of CP violation, neutrino oscillations, particle cosmology, some really fantastic stuff with big words. So hopefully he can help us understand a few of those words here in the conversation. He's also a fellow of the American Physical Society, and he also, and I'd love to dive more into this later, he's also a co-founder of the Society of Catholic Scientists, which we'd love to hear more about. His work, and he's appeared on many different programs and news outlets like First Things, National Review, Wall Street Journal, Weekly Standard, EWTN, lots of different news outlets. And he's also written, he's an author and written some great books, and one of them talks pretty deeply about the intersection of science and religion called Modern Physics and Ancient Faith. And so we'll also have a link to that on the podcast. It's a great book. Definitely recommend you go out and check that out. So actually diving right into that, Professor Barr, if you could tell us a little bit about that book and sort of some of the origins behind it. What were some of the reasons that you decided to write that book, and what were you hoping that people would come away with it?
Well, I've always been annoyed or impatient or disappointed that so many people think that there's a conflict between science and faith. For many years, we had the idea a couple of years ago. The first one, just one was held last year, and that was at MIT. This year there's 7. I hope by next year it'll be dozens, and we hope it takes off to form a community. Religious scientists need to be for more of a community with each other.
I really like that.
Mutual support.
Yeah, that's fantastic. Yeah. And so is that mainly at churches within universities, or is that open, do you think, to all parishes? Or
well, it actually seems to be starting at, I think it's more likely to be able to get off the ground quickly in places that are university towns or big cities where you have relatively large numbers of scientists and science educators. It would be harder to do that in a small town.
Well, hopefully, once you and us here at Purpose Nation and we kind of make some ground roads, then hopefully there should be lots of communities out there. It doesn't have to be university communities who are fans of science and people out there. So let's have lots of gold masses around the country and around the world. I really like that. So thank you for doing that.
That's our goal. We hope this catches on.
Well, we'll do our part to help, and we'll put some information on that on our podcast page. So before we get into too much further, though, I did want to give a quick background for Professor Barr. Very impressive background. He's been in the fields of science and physics for many, many years. He is a professor in the Department of Physics and Astronomy at the University of Delaware and is also the director of the Bartol Research Institute.
Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and today we have an awesome show for you. I'm really looking forward to it. We're speaking with an accomplished physicist, author, and Catholic who's on the front lines of faith and science discussions, Professor Stephen Barr. Professor Barr, welcome to the Purpose Nation podcast.
Well, thank you for having me on.
Well, we're very glad to have you on. It's also great timing having you on the show today. So today is November 15th, and as I believe this would be, for Catholics, the feast of St. Albert the Great, who, as I understand it, is the Catholic patron saint of sciences.
He is indeed, and that's right. And in fact, he lived in the 13th century, and he was actually a scientist and a bishop and a theologian and a philosopher. Yeah, so that's why he's the patron saint of scientists. He actually did some significant scientific work.
Well, that's interesting. So great. It's a blessing to have you on the show today. As I understand, he was also a mentor for St. Thomas Aquinas.
Yes. Yeah, he was his teacher. Right.
He also seemed to be very broad, and so he did all kinds, as you mentioned. He did all. It's kind of rare today, right, to have that sort of person